All right, I think it is time to kick off and get started. Thank you all for joining. This is the Platform 9 fortnightly. That means every 2 weeks. Ask Us Anything sessions. So please, if you have questions, ask. We run these sessions for everyone to dial in, interact with us, hopefully learn together, learn a little bit about our product, but most importantly, help enable people in their journey to learning Kubernetes or even in evolving their production deployments. I am going to click share my screen and pull up slides just because sometimes a black screen can be a little bit boring to stare at. If there are no questions, there's definitely content that we can jump into immediately. But without further ado, I'm going to get started. Today's session is on Ingress and Ingress controllers. Personally, as I've gone through my journey of learning Kubernetes, this is one of the items that I think is quite tricky, complicated, prone to error, and also required. I think it's a great concept, and it's definitely something that we can see evolving within the upstream community as well. And if you're getting started, I think it's one of those concepts that you sort of ask the question, well, what is this thing doing and why do I need to use it? So hopefully we can answer some of those questions today. On this session, if you want to ask questions, we've got a public Slack that you can jump into. There's an AMA channel there. We've got some people from our support team that look at that whilst we're live and presenting here. If you want to get started and you don't have Kubernetes going, we have a free Kubernetes platform that's free forever as long as you've got clusters running. So feel free to go to platform9.com and spin one of those up and follow along if you like. And please do share this recording. And if you think these have been useful, share them with your friends because we run them every 2 weeks. If there's a future topic we'd like us to cover, please do let us know as well. Today, we're going to go through a number of different pieces for Ingress and Kubernetes, not just Platform 9's approach or take on this. If we jump into any specific demos, we've been using the NGINX Ingress controller, which is one of the ones that is available to the Kubernetes, I guess, platform. There's many others out there. Happy to have a discussion around those as well to the best of our abilities. And today, there's myself, Chris, who is speaking, and we also have Mithil, who is one of our long-standing employees, lives in the network world, worked across OpenStack Neutron, and is now being sort of, I'd say, arms deep into the world of 4G, 5G, containerized network functions, IPv6 stacks, for Kubernetes, some dual stack stuff, instrumental in building out and supporting some of our more advanced features, which is our network operator and Luigi there. So a great co-host. We also have Arun, who leads our Kubernetes engineering team, on with us as well. Another networking focused software engineer, also gone through the world of OpenStack and has been living and breathing the world of Kubernetes networking, Ingress, load balancers, and everything for the past couple of years. So hopefully between the three of us and other Platform 9ers that are on the call, we will be able to answer your questions. And with that, I'm going to look at Q&A and see if we can start with questions and avoid my slides. There's also chat that we can jump into. All right, there is a question here already. Any examples or talk through of using Mithil LB with Ingress would be good. Reading best practices that are both needed for LB with Mithil entries and Ingress. I think that's a great question. That's definitely one of the items that I personally have struggled with. I think when people go into Ingress, it's like, well, what's going on? How does Ingress work? Do I need a load balancer? Can I run it without a load balancer? How do I use the two together is basically this opening question. I'm going to bring Mithil in for this one as well. If we're deploying a cluster, Mithil, with, let's say it's on what we call bare OS, so just a VM or physical nodes, we've deployed MetaLB. How do we start using Ingress to route from, let's say, one domain using subpaths to different backend services?
Sure, yeah. So with Ingress, you either create it pointing to a host port if it's a bare OS cluster, or you can point it to a load balancer with a load balancer IP. And it's recommended that if you do have multiple load balancer IPs, you pick one so that it doesn't bounce around. And to answer your question, Chris, you could, within the Ingress object, you could have specific paths in there and route services to a specific path.
Yeah, so that's like this one here, right? So unfortunately, sometimes these things, when it comes to Kubernetes, ends up to be you have to present YAML files, which isn't entirely helpful. So this is a very simple Ingress resource that's been defined. So we've kind of jumped ahead here in the world of Ingress, and we're saying we've got an Ingress controller deployed, and we've deployed it to leverage a load balancer. And now we want to define a Ingress resource that can work off of different paths, right? So there's routing rules that can work off of hosts and paths. And I think one of the concepts that gets a bit tricky is this concept of hosts, and then the path that comes in on the request as well. Can you sort of drill into that a bit, Mithil?
Mm-hmm. Sure. So the typically the host IP is, if you do have with HTTPS, if you have certificates associated with that FQDN, you could associate the Ingress resource to that. And the path is essentially a sub-resource to that host URL. So essentially, if you want to reach your test first service here, you would go to my.platform9.app/1, and all requests to that URL would be routed to the test first service.
And so my.platform9.app as a FQDN obviously needs to be pointing to the load balancer, correct?
Yes.
And that's all managed external from the Platform 9 and a Kubernetes cluster.
That is correct, yeah.
So that's one piece, and I think it's a tricky part when I'm playing around personally with NGINX and Ingress. I drop the host rule completely and just go with paths. Some of this is also dependent on the application as well. So if I go,
by default, the host rule, if you don't have a host rule in there, it takes in all hosts. So it doesn't really check for the host you are, the FQDN. It just looks at the path at that point. So at that point, you could have an IP, you could have your load balancers FQDN. Okay.
So if I have multiple, let's say I have multiple domains pointing to my load balancer IPs, Ingress is able to handle each of those independently, right?
Yep.
So then I could have my test.platform9.app as one FQDN for my, say, testing deployment and a testing namespace for my applications in there. And then I could have this as my production one, all running in the same cluster with a load balancer receiving those requests.
Yes, that is correct. Yep.
And this stuff gets complicated pretty quick. I think the tricky part is I'm just going to go up to a bit of the about Ingress at the top here. So why do people go to Ingress and not just use a load balancer? One part of using Ingress is to be able to sort of do what we were just sort of talking about there, which is split incoming traffic from a domain, a fully qualified domain, on the subpaths. So you can have 2 independent services in the back end, or 3 or 4 or 5, and based on the path and the regular expression that you put into the ingress resource that you've defined, you can start routing that traffic independently. There's also features like SSL offload that a load balancer won't necessarily be doing, and it also enables you to expose more apps on a more limited set of IP addresses as well, which is, I guess, a unique capability. If we look at a cluster, and this is a true 101, and say, how do we get access to things running within a cluster itself? And I think this is one of those things on the journey to learning Kubernetes that a lot of people hit very quickly. It's like, all right, I've got a cluster and I used Helm and I deployed a chart. It's now running. I can't get access to it. Maybe it was deployed to use a load balancer and you don't have one. Maybe you deployed it and it just doesn't have an external service configuration. So one of those ways of doing it is to use a node port. You can see there that it gives external access. That's going to give external access to an IP that's part of the cluster to the port that service is running on, which is fine if you're just testing and learning, and that's a pretty good way to get going. It's not going to scale to production. You'll see cluster IPs are here. They're all internal to the cluster, hence their name. Load balancers, if you're using cloud deployments, they come natively with them. If you're doing a bare metal or virtual machine one, that's something you're going to have to manage yourself. Or if you're using Platform 9, we'll put Metal LB down for you. The requirement there, though, is you have to provide it an IP address range that's reserved, so it doesn't get obliterated by something else on your network. That then allows you to hit specific IP addresses. Now, if you deploy let's say a complicated microservices application, you might assign that entire service to one IP address, but then want to, depending on the route of the request coming in, route that traffic to a different service. And that's where Ingress comes in. So you can start applying routing rules, and that is what we're just displaying in terms of the Ingress resource as well. So it enables some extra flexibility, extra routing, as well as being able to terminate encryption as well. How does Ingress work? If we're going to go completely 101, Ingress is a native Kubernetes concept. It's not necessarily in your clusters by default. Platform 9 does not deploy an Ingress controller right now by default. That's something we're working on. When you add a controller and there's multiple in the market to choose from, you then have the ability to create Ingress resources. And that's that YAML spec we were just talking about, right? It's for a request coming in on a given fully qualified domain name or not. If it matches this path, send that data to this particular service that is running within your Kubernetes cluster. And then with everything in Kubernetes, there's synchronization that keeps all of this in check and looks for those changes using all of the Kubernetes native constructs there. So when you update an Ingress resource, it's automatically going to get consumed and map it to the backend service for you. There's also the specific caveat here that Ingress is really focused on HTTP and HTTPS type of traffic. So that's a super high level Kubernetes Ingress 101. I've got some demo stuff here that we can jump into if we need to or want to. 2 catches that we've done there. I build a lot of clusters without a load balancer, so I've been changing my Ingress controller deployment to use a node port, which means I can hit one of the IP addresses that's part of my cluster, and I can define ingresses off of that for my Ingress resources. So that's a great way to get going, and that's super easy to change if you're doing a deployment using the upstream NGINX Ingress Helm chart to get going. The default is with a load balancer, and that'll work on any cloud deployment that has a load balancer, which is pretty much all of them. And with here, I can see there's more questions coming in, so I think we switch to that because that is what this session is all about. All right. Let's see the first question. Around Mithil LB and a tenant service. Arun or Mithil, there's a question from Jonas, and I'm not sure if I'm just not reading it correctly. It is in the chat.
Yeah, so I did take a look at a couple of questions. So on the tenant service, I would like to know what tenant service is being referred to there. I don't know if the attendees can unmute and talk, but more generically though, MetalLB can you can change the configuration or IP pool for MetalLB itself, and this is very possible. Even on the Platform 9 managed Kubernetes platform, this is possible. There are some caveats to it. When changing the IP pool within MetalLB itself, you need to make sure that the new pool that you're planning to use also encapsulates all of the other IPs that have been already provided to the services. MetalLB internally doesn't, does not delete those services which may have IPs outside of the new IP pool, but it will throw errors, and it will essentially not pick up your new configuration. So there are some bells and whistles built into MetalLB, so that way you don't kind of shoot yourself on the foot. But yeah, totally, you should be able to change the IP pool, not just change a particular IP pool, but also add additional IP pools to the MetalLB configuration. And it's essentially a kubectl configured, and that will persist in all of the Kubernetes environments. For managed services, though, you need to see. It depends on each managed service, right? So I can't talk for all other managed services, but for Platform 9, for example, we do have a way to edit that through our API. So yeah, I don't know if that answers your question, because I'm not sure what tenant service you refer to, but yeah, from a generic MetalLB config perspective, IP pools are very changeable.
Yeah, hopefully.
Yeah, and I also saw another question about Ingress and when you use an Ingress on AWS, it does create a node port automatically, but then trying to connect to that node port directly does not work. Whereas if you create a node port type Ingress, then or a load balancer, then that works. Yes, that's not IP tables magic, but rather security groups. So AWS, the Kubernetes cloud provider, automatically does add security group rules, and for the instance group itself. So that would prevent, assuming that all of your worker nodes are within an within a autoscaling group, then there is going to be an instance security group that is associated with all of these instances. So there you're going to have a security group rule that would prevent or would allow traffic only from that Ingress load balancer endpoint into the node. I just saw that additional question, so just wanted to answer that as well. Back over to you, Chris.
No, that was good. Jonas just responded. So he said, what we saw was the IP pool change back to the config that was created when entered during the installation. So Jonas, if you're talking about Platform 9 and deploying MetalLB, if you have changed the configuration directly on the cluster, we will override that because we treat the management plane as a source of truth. There is an API that you can use to adjust the CIDR, and we have a new release coming out. We'll be upgrading the free tier environment as well as our growth customers and our enterprise users for next week. when you upgrade your clusters to 1.20, that's going to introduce a new management framework for add-ons, and there will be a little bit more of a simple API for adjusting the MetalLB ranges there. So we can do it today if you like. Slack is probably the best way to get hold of one of us, and we can look at getting on a Zoom to go through the current way, or we can wait till next week, upgrade the cluster to 120, and then use the add-on management API to adjust the CIDR range there. I think that's what you were talking about, and that will permanently change the CIDR range. We'll be working on UI changes to enable all the add-on management in the coming weeks as well. We sort of start with APIs and then progress to the UI configurations. Kirk is saying for MetalLB in the UI, you can't find it. If you're talking about deploying, I'm going to click escape, go to my environment, infrastructure, create cluster. When you're doing either a Bare OS on a VM or a physical server, it's on the first page. There's a deploy MetalLB in layer 2 mode. This allows you to put in the IP address ranges. What we've been talking about is the ability to alter these. So we can do that today. We just haven't made it public. Starting next week with the 5.2 release, we will be publishing documentation on using the APIs to update MetalLB and a few other add-ons that are part of the platform as well. Cool. All right. There's a question about what is the most common deployment in production? QProxy, NGINX, MetalLB, network load balancers, application load balancers from cloud providers, and the pros and cons. I think that's a great question. And it's something that we've discussed internally. I know Arun and I have. Ingress is limited to HTTP, right, Arun?
There are so traffic controller is one which allows you to also do L4 Ingress. So there are options, but coming down to the set of choices that was asked here about QProxy, NGINX, MetalLB, and since we are specifically talking about a cloud provider or public clouds, I think like any answer goes for a deep question like this, it would be it depends. But just to generalize, I think QProxy and NGINX are pretty common out there, especially on the cloud side. MetalLB is not really an Ingress controller. So MetalLB is more of a load balancer alternative to on-prem deployments. So essentially what MetalLB does is it allows you to create load balancer type Kubernetes services and then provide a load balancer type solution without actually needing a physical load balancer on-prem in software. So MetalLB is something that I'll remove from that list. So if you talk about QProxy, NGINX, I believe we have a large comparison white paper on the various ingresses. Both are pretty, I've seen that both being used pretty commonly. And when it comes to fronting it with a load balancer, being ALB or ELB, NLB, most people use Ingress with L7, HTTP, HTTPS. So it is enough if you use an application load balancer. Comparatively, if you look at AWS, to take an example specifically, the Amazon cloud, if you create an ELB, and if you create a classic ELB, it's essentially a network load balancer. And ELBs are newer objects, which you need to create explicitly. I think there is a price difference as well. So it might be that ELB is a little less expensive. It does do HTTPS, TLS termination. So there are advantages, disadvantages. It purely depends on use case, but most common ones have been QProxy, NGINX plus ALB for AWS, for example.
Yeah, I think there's other other items to look at here. NGINX, they both have open source variants. NGINX has been acquired by F5, and they've started publishing Ingress controllers with new features and supportability as well. So depending on your environment and how your company wants to operate and what level of support you're looking for, I would also say look at what you're able to get vendor-based support for, because that might be beneficial for your business and the applications you're operating. There's an update to this question that came in around Istio Ingress, and how does that fit into the world of Ingress controllers?
Mithil, do you want to take that one? Or I can.
Sure. Yeah. I mean, Istio is more than just an Ingress controller. It's also a service mesh, and I think it depends on, like Arun said, it depends on the use case. But if you do plan on having service meshes, I would recommend also having Istio there as the Ingress controller. I don't know if you have any thoughts on that, Arun.
Yeah. So I think it is also interesting to talk about the future of Ingress, or rather maybe even the history of the way Ingress came to be within Kubernetes. In a very quick spiel, Ingress was supposed to be this thing that allows you to have a single endpoint and on the L7 side or application side, and be able to route traffic across multiple services with the same IP port fronting it. Essentially, a gateway for you, right? Assuming you're running multiple websites or multiple applications that need access to the outside world, you want firewalling to be present in front of it, making that easy. Imagine, let's say you have 50 services and all of these are load balancers in AWS, for example. That means that you now have 50 different security service areas to cover and figure out what type of traffic moves in and out, what's safe, what's unsafe, and basically apply those security policies on them, versus having an Ingress kind of reduces that surface area quite a bit. So Ingress came in that sense, and one of the main tenets to any Kubernetes object has been simplicity, right? So Ingress has been designed from a thought process of being simple, just making sure that you have different routes, which then you'll be able to select backend deployments or services and then route traffic accordingly. It doesn't do a lot of complex things like traffic engineering, traffic shaping, firewalling, being able to, being able to say, if there's a heavy load, then load balance it to a different service, do blue-green type deployments where you want to send 10% of traffic here and 50% there. It does do, but not to a large degree. And at that point, and when you start seeing such requirements, that's where a service mesh kind of becomes pretty interesting technology to look at. Istio works, has a lot of features. It has been overloaded. The newer version of Istio off late, the community has been moving to making sure that it's easier to use and does a lot less, but much better, rather than being a generalist solution for a lot of things. I mean, Istio was doing end-to-end pod-to-pod TLS. It used to give you telemetry, it gives you a API gateway of sorts, it gives you service discovery and the whole service mesh concept in that sense. It did Ingress to some extent. So it did a lot of things, right? So, but going back to your question of Istio versus these Ingresses, again, it depends. If you're, Istio also works well with things like NGINX or QProxy, right? And it internally deploys Envoy proxy as a sidecar container to do some of these things. So it all comes down to choice and it depends. But if you're anyway going to use Istio internally, then I think it's worth also looking at Istio for Ingress. But yeah, that shouldn't stop you from exploring NGINX or QProxy either, because they are a more dedicated Ingress solutions out there, right? So it all depends on the depth of technology and options from a traffic engineering networking that you need, and which project or software allows you to do that out of the box. Maybe a long, convoluted answer, but essentially, yeah, you should probably look at all of these options and then consider depending on your use case and what you deploy within your cluster.
Like all things Kubernetes, I feel like it goes from a simple question to complicated in a simple step. What I might do just quickly is a super quick 101 on Ingress deployments. I do have this in the slides, and we'll help publish them. So this is platform 9. I've got a few different clusters running. I've got one in Azure that's deleting. I've got this BearOS one that's disconnected. That's a VM on my laptop. I have a Rook cluster that's got 2 nodes in it. I also have a Portworx cluster. It's an upgrade pending. So as I've mentioned earlier, we don't deploy Ingress out of the box. You do have a few options for adding Ingress. You can go the tried and true, log in, download a kube config and use kubectl. That is one way of adding Ingress. We've recently added an application catalog, and we are personally going through the process of building out a default catalog with different Helm-based apps to make them really easy to deploy and get into your clusters. So if you're running in platform 9 and you just want to get Ingress going quickly, we're going to specify versions that will work with and without MetalLB. So I don't run MetalLB, so I can just pick this particular one, and I have a dev flag turned on if you are wondering what this blue is on the side here. Please ignore that. So this is the default values.yaml for NGINX Ingress. And what we've done is we've customized it to use a node port. And I am scrolling through this with intent to find that type node port here. So we've already changed it, and that's what we're building out this chart to target. So if you don't have a load balancer running, this is the flag you need to change in terms of a Helm chart values.yaml file. If you're doing this from your own terminal or client, you'll need to download that, grab your favorite text editor of choice, and come in and grab the values.yaml file for the deployment and find the same setting in here. And that's the same for many Helm charts and applications. You can give the deployment a name, Ingress, choose your cluster, and this is basically everything that can get done in, actually I don't want to deploy it there, I want to deploy it here. Choose a namespace that you want to deploy it to. I'm just going to click add Ingress. And this is exactly what you would be doing from the command line if you're choosing to do Ingress from Helm itself. So I'm saying deploy version 3.30. I'm using the version that we're building out that has no load balancer. So it uses node port, and I click deploy. I really should turn this development flag off. So that's going to deploy the Ingress controller. From a how do I test it perspective, there's a question in here around AWS. So I've got a super simple .NET app running. It doesn't have any backend storage requirements or anything. This is the YAML content. As you can see, it's a pretty straightforward thing. It's pulling an image from Microsoft, and it's creating a deployment with some pods in it, and it's also creating a service. It's called My Sample Service. You can see this service definition doesn't actually have any anything exposing it externally. So if I've deployed that and I want to access it, I can run kubectl proxy and hit a local host, and kubectl proxy will route that based on the namespace my sample app to that service. Obviously, that's not a great way to get access to the application. So if you've deployed an Ingress controller and you're using, say, this sample app, the next step is to create the resource and you're done. It's going to map together. So what I just went through from the UI is exactly this process. So you can see at the top, I created a namespace. I then used Helm, added the NGINX upstream repo from Kubernetes, not the NGINX repo itself from NGINX. And then I've installed it. I specified the namespace, and because I've been using a customized values.yaml file, I created that locally and had that available in my terminal to deploy. Once that deploys, you're going to see a number of services and pods running. Specifically in the service bucket of NGINX, you'll see a node port deployment, and you'll see the internal cluster IPs, and then you'll be able to see the ports that are external, right? So if you hit one of the nodes of your Kubernetes cluster, you will be able to hit NGINX if you hit 31175 or 3675 as well. The next step is to create the Ingress resource. So kubectl apply -f, putting out a file. This is a very simple catch-all. Just to really call that out there, we're talking about simple name. We're putting an annotation there saying it is of class NGINX to make sure it links up correctly to the Ingress controller. I removed that host mapping in there, and I've just said for basically all HTTP traffic that comes in on this path, point all of it to the service of name my sample service and to the port number 80. So that's going to catch absolutely everything that's coming in and point it directly to that service. The end result of that is you can get to that backend service by hitting the cluster. That's a super quick 101. I'm just going to click escape there for a second and go back to questions. I saw that it was a bit of an ask to sort of do a really quick intro to Ingress to get everyone on the same page. So hopefully that helps everyone get going. If a 101 Ingress session is of use, I'm more than happy to set one of those up as well. To go back to a question from Rajesh, it said, whenever you expose an application of an Ingress path in AWS, it's assigning a node port. But how do you access it with the node port itself not working?
Hey, Chris, I kind of answered that already. So I think it was more of a question about how AWS, when you create an Ingress, it does create a node port on the Kubernetes side, but then if you try to use that node port east-west within the cluster, then that doesn't work. But whereas if you expose an Ingress on node port, then it works. So essentially the answer to that was that there are security group rules that get added, which kind of limit the communication channel between the entities. When you create an Ingress with load balancer, then it is limited to that Ingress and the instances. The security groups are applied to all of the instances, especially when an instance is created within an ESG. So I think so that was covered already, Chris.
All right, cool. Let's see what else is coming in. There's a question that's around QProxy relate to Ingress controller like NGINX. I'm going to assume you mean like the QProxy that you can invoke to run to then access resources directly in the cluster?
I think they might mean the actual QProxy component that does. So I think it's from a relation perspective, Ingress controllers, you can look at them as north-south entities. So essentially, traffic that comes out from outside of the cluster inbound to a particular service. And QProxy is more east-west service routing within Kubernetes. So the way it's related is Ingress controllers allow you to get traffic from outside of the cluster, but then once it does land into the cluster on one of the nodes, QProxy is still in play, where it kind of does the service routing through cluster IP within your Kubernetes cluster. So it essentially goes hand in hand when it comes to QProxy and an Ingress controller.
There's a question around EKS upgrades and a load balancer getting recreated from Rajesh. I think, Arun, you've replied in text on that one already, right?
Yep, I did. We can actually talk about it too if others are interested. Essentially, I mean, EKS might be a singleton. I'm not too sure about it, but in general, when you upgrade Kubernetes or upgrade a cluster, service objects are as is, or they don't get deleted. So technically, the load balancer endpoint should not change either. So that should be as is. However, if the service object is deleted or recreated, then yes, the load balancer endpoint would change. At that point, if you really need the DNS entry in Route 53 that maps to the load balancer intact or get updated, then I think one way to do that is to make sure that the Ingress object is also recreated when the service object is recreated.
That makes sense. That makes sense to me. There's another question. I think this is a pretty deep question. Is around URL management capabilities for multiple clusters. I think this is sort of getting into the realm of, some people are talking about like cross-cluster service mesh. Rajesh, just to clarify, you're talking about managing multiple clusters running the same apps, like globally distributed, or are you looking at clusters running different applications and sort of managing the configuration there? Each cluster is independent. Yeah, I mean, the sort of the rise of GitOps around defining your ingress there. I think this is one of the challenges that a lot of people in the community are grappling with, especially with people that are, in businesses that are just getting into microservices and sort of understanding the complexities there. I'm not aware of a product that's out there that's sort of looking at these definitions and allowing you to simply manage them in a visual non-YAML way. I'm not sure if Arun or maybe Mithil have come across something that can help simplify managing those definitions. En masse.
I am not aware of something like this either.
So I believe there are some tools that allow you to visualize YAMLs, especially, but as far as I know, they're more application oriented than infrastructure oriented. I forget the names, but there are both open source and vendor-based tools that allow you to kind of make Kubernetes app development easy to some extent. Then again, if the question is specifically for multi-cluster and something that does across multiple clusters, yeah, I'm not too sure. I don't know.
Yeah, I know. We work quite a lot with Tigera around Calico. Their enterprise product does come with sort of like services and dependency mapping, but they're not really at that ingress layer. So that's sort of a tricky one, because you need to be aware of each of the classes and bringing it in. I mean, it's a great problem to throw out there. My brain's kind of thinking about ways to solve that up front. Yeah, that's a good business idea. If I put my business hat on, might start tracking that as something that's interesting for us to look at as well.
Yeah, and I think there was another question, I believe from Rajesh, around what would we do from a deployment perspective, multiple ingresses per cluster versus one ingress for everything in one cluster. Might be somewhat related to multi-cluster management there, but if we have to speak to about ingresses and a single cluster, then I've seen use cases where people use multiple ingress controllers. They could be by namespace, or they could be by a set of applications. So there's something called an ingress class that you can use to specify which ingress will kind of work with which backend services, and that way you're able to divide. So for example, you have two teams, right? One team is working on, say, a specific application, and another team is working on another application altogether. They want to be able to use Ingress to get to their services for their clients. And say one of them is working on some traffic engineering from an upgrade perspective, where they want to split traffic across their version services. So ingress classes kind of help here, where you could have multiple ingress controllers and just separate it out completely, or you could go with a new gateway API, where you're able to separate out these applications and services as part of gateways and routes, and use it that way too. So again, unfortunately, the answer is it depends. In general, though, I've seen people use a single ingress controller in their cluster. But as and when the cluster grows and the number of applications grows to a very big amount, then you can see about deploying multiple ingress controllers within the cluster. Now, if you go with a added question to this answer and ask me, would you recommend deploying the same ingress controller as multiple objects versus multiple different types of ingress controllers? I unfortunately don't have an answer to that. In fact, I've not tried it, but I believe multiple ingresses should be able to work together in a Kubernetes cluster. It's another, just came to my mind, would be worth trying. Especially, I can see some of the apps require an L7 ingress, and then you might have some other apps, like say you're running etcd or an S3 type service where you need TLS and you need L4 like traffic to your service. You might need an L4 ingress. So having traffic and NGINX might be a way to go. I don't know if it's possible. But yeah, definitely a use case is there.
I need to unmute myself to be able to talk. Shankar mentioned Octant and Lens. Yeah, I mean they're great. They're great ways to visualize connecting to the classes and seeing what's set up and configured. Definitely. Another app out there called Infra that you can download. That's a small client that does a very similar thing, as well.
But Octant and Lens, I don't think they do cross-cluster visualization, which is probably what Rajesh was looking for.
Yeah, I definitely know the visualization. I used to product manage an application performance management platform. Some of those are really really well positioned to help with multi-cluster, cross-cluster visualizations of data flow and stuff like that. And some of them do pull in that metadata as well, so you can sort of see the configuration. It's kind of the interception of both of those. There's another question. It's a little bit longer. Let me read it before I start speaking. How to maintain a single manifest that can accommodate, I'm going to assume, applications across multiple Kubernetes versions. That's it. So this is talking about API version changes and maintaining state across those to ensure, I'm assuming that that a manifest is compliant for the APIs that are on 17, 18, 19, 20, 21, 22 into the future. That's a problem that is very common in the industry. It's come up a few times. It's definitely something we've started talking about, attempting to solve. I personally have not gone out and looked in the market about what's available to, I guess, do like almost code scanning or even live checking of how a cluster is being interacted with. I'm not sure if this is slightly off topic to the Ingress topic, but I think it's a good question anyway. I think you're potentially asking, like, how do I know I'm going to deploy something or upgrade my cluster and all of a sudden hit issues? I know, unfortunately, a lot of people sort of do that manually. I know some people will deploy a cluster on the new version, let's say 120, and deploy the wrapper and just wait and see what breaks. Obviously, that's not a great way of doing things, but it is a way of doing it. I'm not sure if Mithil or Arun have got a way that we handle this internally when we're developing, or how we go about that process.
You want to take it, or I can? All right. So yeah. So there are. I kind of see this as two problems or two separate parts to this. One is the application that is being deployed. So let's generalize, not just Ingress, but anything, right? So think about it as a system app that's required to run your cluster or add or provide additional functionality within the cluster. So that's one, the app itself, and the other part is the Kubernetes cluster and the API versioning that Kubernetes brings with as part of an upgrade. So an Ingress resource could change, a load balancer resource could change from an API perspective. So there are two parts here. One is the application itself, and the other is, of course, the Kubernetes version. So assuming that the Kubernetes API or object API does not change, right. So the application normally has backward compatibility and it works with newer Kubernetes version, and that's not a problem. Now, the second part where the API changes, it is definitely a problem. At least internally, what we kind of do this to some extent, but that's where I think one easy answer to that is maybe you should go for a managed service. But yeah, the applications that we deploy, like for example, Core DNS or Metal LB, we make sure that when we upgrade, we test if there are things breaking. If there are, then we have code or we write whatever logic is required to kind of migrate these resources. Hopefully in a zero downtime on the data plane side manner or way. Again, it's not always possible, but that's where we kind of try to do that and bring in that value add. For the applications that we deploy, yes, so definitely the answer is to migrate one chart or manifest for a version of Kubernetes, especially when it is required. So the first thing that it depends on how and what you do as part of upgrade. For example, within Platform 9, we kind of first look at the release notes, see what's changed, what's not changed, bring up a new Kubernetes version, see what breaks, what doesn't break, and then sometimes something is missed in the release notes, and then we try to add that back with the community. And so essentially what happens is we come to know what's broken or what doesn't work and see if what the mitigation is. One of the mitigation factors could be that we use an older API endpoint or older object. It could be deprecated, but it still works. So, and then you need to make sure that when it's deprecated, you take that into account and start moving or coming up with a migration mitigation plan so that when it's dropped, you don't kind of get into deep waters where the data plane is down.
Yeah, I think that's a good answer, and I also think it's kind of like the network one. I think it's one of these ones that is emerging in the industry and ripe for being solved. We are at the top of the hour, so I think we're going to wrap up. We do record these, so if you want to catch anything again, we'll be publishing it to our YouTube channel. Thank you everyone for the questions that came in. It's always good to get some engagement. And if you want to get us in real time, Slack or our community, if you want to try out Platform 9, just go to platform9.com and you can get going right from there. And with that, we'll wrap. Thank you all for your time and have a great day.